Welcome everyone. Let's have another quick lesson on what we are calling as the similarity magic. And today it's a very nice and simple theorem, but extremely useful in problem solving. But we'll be able to quickly give you the proof using things we have learned, and so that's what makes it an exciting lesson for me. So when I first heard of this very well-known theorem known as the power of the point, I was definitely found it very intriguing, and what I didn't know is that this very good-looking result is very easy to prove. So here's the proof. So what is the power of the point? So you have a point outside the circle, and now it really doesn't matter what line you draw in a way in which it intersects the circle in 2 points. It really doesn't matter. So let's label them in the points of intersection as A, B, or A1, B1, or A2, B2. And the theorem says that PA1, PA multiplied by PB doesn't change as you draw different lines. So this is also equal to PA1 into PB1, and that is also equal to PA2 into PB2. So very nice theorem. And if you look at the extreme case, and that is if I draw a tangent to the circle. Now this point, let's call it T, is more like A and B almost merging and forming a single point, and so one can easily guess that this will be equal to pt square. So this is the power of the point of a point outside this circle C with center C. Now let's go through the proof in this lesson, and then that will be the end of the lesson. So here's the proof. All you need to do is draw one construction line, which is not very obvious, but once we draw the construction line, the proof is very simple. So let's draw the two lines P A1, A B, and A1 B1. So here's the construction line. I shall join this point B1 to A and join the line B to A1, and I shall mark out now two triangles. Please note the two triangles that I'm marking out. One may be with the red line, and the other I shall mark out with the yellow line, and you will be able to see that these two triangles share an angle P, a common angle P, and now you can very easily and quickly see that the angles that I am marking are actually equal to each other because of the first theorem that we learned, which is the inscribed angle theorem. See, both the angles that I have marked are inscribed in the same arc A dash, which I am marking with the green line. So with that, we have two angles which are equal, and therefore the yellow triangle is similar to the red triangle, and that is the end of the proof, as you shall see now. So let me write down the red triangle. The red triangle is PBA dash, and that is similar to the yellow triangle, and the yellow triangle is, let us get the angles right, P corresponds to P and B corresponds to B dash. So that would leave A, and so the angle A dash is equal to A, and so by AA the two triangles are similar, and we are almost done with the proof. As you shall see now, the two triangles are similar. Now all that remains to write down is the consequence of this similarity. So you can see now PA dash upon PA is equal to PB upon PB dash, and I think that's all that I shall need. This is a direct consequence of the similarity of the two triangles, and immediately one notices by cross multiplication that PA dash into PB dash is equal to PA into PB, and that is a proof of the power of the point theorem. Now let's quickly just write down here that we used the two wonderful things we have learned, which is similarity and also the most fundamental thing that we learned, inscribed angle theorem. So two good friends coming together to give a wonderful result called the power of the point. Now what I shall do now before I end this lesson is, let's just do the special case, the extreme case of the tangent, because in a slightly different way, because that is also a lot of fun. So let's do that quickly as well. So what are we trying to prove? We are trying to prove that this power of the point is also equal to pt square. So what is pt square for us? We have a point P outside, and this time we have a tangent, and this is P and this is T, and we shall try to prove that the power of the point P is also equal to pt square. And we shall do this in the following way. We'll take a special point here, the center of the circle, and we shall join this diameter. We shall join P to C. We shall join P to C, and therefore and extend it so that in this case the points A, B will actually be the diameter of the circle. Now we already know the power of the point is equal to PA into PB is the power of the point, and now we shall prove that this is also equal to pt square by a simple Pythagoras theorem calculation. So let me do the construction. I have T joined to C, and therefore we have a right angle triangle, and now we shall mark out the radius of the circle. This is also the radius, this is also the radius, and this is also the radius, and let's call PA as x. Let's call PA as x, and therefore let's do a little bit of algebraic calculation now. PA is x, and now we have multiplied by PB, which is x plus 2r, and we shall try to prove that this is equal to pt square. Okay, that's this is what we need to prove. So let's look at the LHS now. LHS is x into x plus 2r, and now RHS is equal to pt square, which is also equal to pc square minus ct square. This is due to Pythagoras because there is a right angle triangle here, so this is due to Pythagoras. And now we just need to substitute. RHS is equal to PC is equal to x plus r whole square and minus ct square, which is equal to r square. Now this is equal to a square minus b square, that is x plus r minus r into x plus r, that is a plus b into a minus b, and that is equal to x into x plus 2r, and that is equal to LHS. As you can see, the LHS is right here, and with that we are done with the proof of the fact that I'm just going to highlight it here, that the power of the point pt square is also equal to pt square. That is, pt square is also equal to PA into PB, which is nothing but the power of the point. So with that, we are done with another magical result of similarity, and in the next class I shall continue with this theme and show you one or two more beautiful magic due to similarity. As of now, we are done. Thank you very much. I'll catch up with you pretty soon.